Okay, hello everyone. I hope everyone had a good tech merge. Say yes. Yes. It's probably the best tech merge ever, right? Yeah. We had an excellent time. I had an excellent time learning about all these great languages here at the conference. All Erlang, Haskell, OCaml, Clojure, ClojureScript, Scala. Did I leave out someone? I mean, a good language. No. We all love F#. F# is great. I didn't hear PHP. Sorry, Joe. Although if Facebook runs on it, well, it's another topic. So we've heard about all these great languages, but the question is, can we actually use them? So here's a question. Who here is stuck on Java, on the JVM? Who has to write Java code? Hands up. That's quite a lot of people. Is someone courageous enough to answer why you're still on the JVM? Who forbids you to use Haskell, or who says you have to use the JVM? Hands up. Who is courageous enough? Clients. Management. So what do the clients say? I mean, do they say they need a JVM, or they don't want a native VM or native code in their system?
They need to maintain the system. And they feel that finding the Java developer is simpler than finding a function.
So it's developers that they don't find.
They don't find. The culture says that we should have a Java developer.
So is that an educational problem? Is that, I mean, who here programs in functional languages? How did you learn to program in functional languages? Who convinced you to do it? Joe. Well, Joe convinced me, so I pointed him. Right. So let's open this up to the panel. What do you think? What is the big barrier? Why are many people not using functional languages? Is it education? Let's start from the left, Kresten.
Well,
so you put your hand up with Java. Are you
I
still?
put my hand up with Java, and that's obviously because we also I'm with the audience here in many ways. We run a software business, and a lot of our customers are these kind of medium to large size enterprises that have the idea that they want to take responsibility. So the situations where we get out of this situation is where we convince the customer that we should take responsibility. In many cases, we not only develop the system but also maintain it and run it and host it. And but I think it's obviously an issue for all this medium scale or enterprise situations. There's the small places or startups that run behind a web service or a web front end or whatnot. They have a lot of freedom to do this kind of thing. Where there's the large scale enterprise, like embedded environments, like you could see Ericsson, for instance, they can afford to do their own stuff inside there. But there's a large middle ground where people are stuck on all kinds of assumptions on context. And it's the only way that we see into that is really building trust with the customers and convincing them that you should trust us, and that's always something that takes time. I mean, very natural.
But trust, you mean to trust in your choice of language?
Trust in all kinds of matters. I mean that goes to a large extent for many things in software development. When you're like a services job, to work effectively, you need to build up a trust relationship with the customer. And a lot of the exercises in doing software development are really about building this trust so that you can actually perform and be professional and be allowed to exercise judgment. So building trust can happen in many ways, of course. Just by sheer authority, things you do outside of context of the project, or by proving on a day-to-day basis that the things you come up with actually work. Yeah, I don't know, maybe I can pass this on to someone else.
So Rich, you wrote closure in Java. Why?
Why did I write closure in Java?
Yes.
Or why did I write closure at all?
Why did you write it in Java? Why not
I wanted specifically to target the JVM. It was one of the design goals of closure to target the JVM and .NET specifically. And specifically to address the concern you raised initially. The customers I had seen could not deploy anything other than on the JVM or .NET. And so I wanted a language that was not C# or Java that could target the JVM and .NET.
So essentially, it's the enterprise says we have only one plug, and that plug is JVM shaped, and if your thing doesn't fit in here, it's out.
I don't think it's much different from hardware or operating systems. If you go into an institution, they have the hardware they have, they run the operating systems they run. If you said, you could run my new software, but it's going to require you to change hardware or operating system, you wouldn't be surprised if they said, I don't think so. I can't afford to make that kind of change. So the VMs have become that kind of an institutionalized component where it's a big decision to take on something other than what they've done already. So yeah, that was an
It's the
objective.
VMs and the platform, I guess, the APIs. And
It's a platform. The VM there is a platform as much as the operating system or hardware is, sure.
So coincidentally, on this side, we have people who write native VMs and native compilers. So Robert, how do you get around the problem of the ubiquitous JVM?
Well,
requirement
we have it easier that we just do Erlang consulting. So if when they come to us, it's because they want to try something in it, or have something written in Erlang, or want to try something in Erlang.
So they've already made up the decision. They made up their
They
minds.
have made up the decision. Okay, we might have discussed with them beforehand to help them convince them to make that decision or to make that test. But they will not come to us to ask us to do something in Java. I don't think they would anyway. We could probably do it, but yes. No. I have a question. I'm asking this out of ignorance. Is it really difficult to get hold of functional programmers? I know everyone says that, but I don't know. I'm asking because I don't know. Is that really a problem if you don't advertise for them?
No.
No.
Who says yes?
I would say yes. Sean, I
Okay.
They might not be cheap programmers.
Yes.
Well, okay, but what about good programmers?
People who actually can not be educating good programmers can afford that new language, but getting somebody to come on they want,
Actually, I have the mic here.
that's probably an issue.
So you can't find.
You can find, but if you want to find many, it's not that. And depending on how many, okay, I got 33 nationalities up in Stockholm. I'm relocating people to Stockholm just because I'm having a hard time finding them. So anybody want to come to Stockholm, you give me a call.
Okay, no, I was just, as I was just curious. I asked because I don't know the answer.
They didn't want to get programmers in Stockholm. Yeah.
Yeah. We got a shop in Tel Aviv as well.
But apart from that, I say, seeing we do that consulting in Erlang, we don't really have that problem. At least not when they get to us. Not beforehand. I can just say as a comment too that many systems using Erlang will have things written in other languages as well. Might be Java, might be something else. So I think many of the applications aren't one language.
So Simon, how do you do with your work on the Haskell compiler? Do you see that sort of problem? Because you compile to native code, I think.
Right, so I think native code is kind of an orthogonal issue because you can do bytecode compiling on top of the Haskell runtime. We have an interpreter, for example. But so the reason we have our own runtime is because Haskell has historically been a research language, and we like to try out lots of different ideas, and it's much easier to do that if you can go and tinker in the runtime and implement new things like transactional memory and so on. So I suppose the places we see Haskell used are places where you can do an entire component in Haskell and then talk to other languages via JSON or Thrift or something like that. But there has been calls over the years for a Haskell implementation on top of the JVM, and it's just that it's a huge amount of effort, and it would probably not be very performant and would lack some of the.
There's the
confidence.
question, would it be possible at all? I mean, it would be possible, of course, but it would probably be slow, inefficient, on the .NET VM.
Yes, it would be slow because, well, for one reason, we've got lazy evaluation, for better or worse. Lazy evaluation really needs some hooks in the garbage collector and other parts of the runtime system to make it really efficient. And also there's the threads issue. So in Haskell we've got lightweight threads, which we think are really important. And Erlang, of course, has the same. And if you're on the JVM, you'd have to sort of simulate threads using some kind of, using the sort of ACCA methods and that sort of thing. So for one reason or another, it wouldn't be very performant, and the results wouldn't be as good as having a tailored runtime, particularly for Haskell.
So there's the trend of building languages for the JVM. We have Kresten built Erlang, we have ports of JRuby and Python and Ruby and Scala and Clojure. And I think one of the arguments is the powerful backends, the garbage collectors, and the ecosystem. But are we leaving something on the table? I mean, with compiling to native code, I mean, Simon, as you said, we can be much more efficient. Is it really much more efficient? Are there things that just, is it worth the trade-off to compile to native code instead of taking the performance hit on the JVM?
Well, actually, I'll try to answer that, because when you look at least the languages represented here, efficiency isn't really the most important thing. It's like expressiveness, it's making it easy to write complex programs of various kinds. It's making dense programs that are easy to maintain. It's a lot of other issues. It's making fault-tolerant systems, and so this focus on efficiency. I mean, it's like the top of the iceberg that everybody's looking at, that Joe was showing this morning. And I think, most of the alternative programming community that come here go there for these various other reasons. And they realize that there's a lot of value in that space. I don't know, I mean, if there's comments on that from the audience, but generally, if you really want performance, then you probably often want other routes, and if that's your primary concern. But that's typically situations where you can spend a lot of effort to optimizing a particular problem in a very specific way. In the general broad context, there's always complexity in the code and in the system, figuring out ways of simplifying that by doing systems design, doing fault handling in correct ways, and doing very nice abstract algorithms over data structures.
But are we here talking about performance or some performance characteristics that are surprising for the developer? I mean, I do something and suddenly it's maybe lazy or delayed, and suddenly things grow and become completely different. I mean, in runtime and performance characteristics. So it's not is it faster or not? But in this algorithm, I normally implement it that way. But since there is behind a GVM or something else, then it's becoming completely slow because of some. So isn't this the question? And this is when you have much more comfort when you're building your own VM, because you know your language and you don't have any encoding that will break these kind of things.
Well,
I was going to say, I mean, when you design building your own VM, you of course target that for the properties of the language you're doing it for. I mean, JVM's done that as well. I mean, it's targeted for Java. Yes, you can run lots of stuff on top of it, but it's still targeted for Java. If you're running on top of the beam, that's targeted for Erlang, and optimizes that type of operation. You can sort of run other languages on top of the beam, but unless they're quite close to Erlang, it won't do it very efficiently. And it's just the way it is, for example. But it does Erlang things very well, because that's what it's supposed to do. I was saying, assume it's the same for the Haskell as well. I mean, Haskell runs Haskell well, but
I think you'd have trouble running anything other than Haskell on top of the Haskell runtime.
Yeah, how many languages do you have that compile to Haskell?
That compile to Haskell. Well, so Haskell is the basis of many, many DSLs. It's a very good language within DSLs.
So there's lots of languages that do that.
So Haskell is the ultimate imperative language, as we all know.
Yes.
So,
yeah, wrap it all in a modad and it works.
You can run BASIC on top of Haskell. Leonard will tell you about it.
so we were talking about VMs here, but native compilation, does that still have a future in that regard? Because portability, if you compile for x86, we have one binary that's tied to x86.
Yeah, so I mean, it's obviously a trade-off. Right? If you do ahead of time native compilation, then you've generated code for one particular architecture, and you've baked in a bunch of details about how exactly you want to run the program when you compile it. So if you defer all that, then you can do much more at runtime. You can decide to profile it, or you can decide to add some debugging stuff, or run it on a different architecture. Clearly there's a trade-off there, I think, but there's no reason we couldn't build the JIT for Haskell. There's just nothing fundamental in the language that says we have to compile natively. It's just that we've done a lot of research on how to optimize functional languages, and you need to spend a lot of time analyzing the program at compile time to do that. So there's nothing fundamental, I think.
So here's a question. So we heard about all these great languages, but let's say there's a language that hasn't been invented yet. What will that use? Will the future Rich Hickey or future Kresten or future Robert or future Simon, will they target the JVM or something else? Or do we just sit down and write a simple VM? Will that be performant enough? Will that be, or maybe the trade-off is you get all these benefits like fault tolerance, robustness. If you were,
depends on what kind of language that would be that you want to run.
well, the next trend is of course a logic language. The next Prolog.
I don't know anything about Prolog VMs.
I think, Rich, that's your area.
Well, Prologs themselves are, we're one of the leaders in specialized abstract machines, right, for their interpretation. So I don't know why a Prolog wouldn't be that way. I agree with Kresten. I think it depends on what kind of language it was. I don't think you see a lot of languages with sophisticated VMs. Most of these VMs are very old and have an incredible amount of man-years behind them. Most languages that are new are either sitting on an existing VM, and then it's almost always the JVM or .NET, or have no VM. They're interpreters, and they don't have a surrounding infrastructure.
Yeah, I agree. It depends on how well your language fits an existing VM, like the JVM or something else. If it fits it, unless that VM has some properties you don't want, then there's no reason not to pick one. Of course, unless you want to enjoy the fun of writing your own VM. There's always that, cutting all of that. But
I recommend it.
yeah, it's very satisfying when the first thing works. But I mean, apart from that, if your language fits onto some other existing VM, of course, use it. There's nothing saying you shouldn't use it.
Or design your language for the VM, like F#.
Yeah, you can do that, yes.
Or closure.
Yes.
So, to some degree, it was definitely part of the design.
Oh, absolutely.
There's a question about, for instance, Scala is the typical language designed for the JVM, yet it suffers big problems with backwards compatibility with their traits implementation. So apparently, the JVM still causes problem even if you design for it. Or I mean, Rich, for instance, I'm sure you had some fine features that wanted to put into closure but couldn't, like tail recursion. Everybody loves tail recursion.
I would love it if the JVM had it. It would be great, sure. But engineering is about trade-offs, right? It's not about idealism necessarily. So, take what you get, and if you get it for free, You feel pretty good about it.
Yeah. Well, when we started, the JVM didn't exist, so it wasn't an option. And yeah, I can just say one thing. I mean, if you do your own VM, yes, it's a lot of effort to do it. If you want to make one that's good and has good quality and can be used, for example, in production systems, it's definitely not a trivial thing to do. So yeah, it's fun doing it, but if you seriously want to use your language, it's a lot of work to do it and to maintain it as well, and to update it and to improve it, etc., etc. And I don't know how many man hours or how many man years per year go into improving the JVM or working with that. It takes a lot of time to do that, which is one reason against not doing it, unless there's a specific reason for doing it.
So you see the ecosystem as a massive argument in favor of the JVM, all those millions of libraries. And obviously, as we say, that's a trade-off. You have to deal with static VM, but you get all these benefits, all the ecosystem. Is there a way, how could we get over this how can we twist this trade-off? How can we make the trade-off in favor of new VMs that can then be more flexible, that be like the Erlang VM that offers isolation? But how can we get rid of the library advantage of the JVM? Any idea? Kresten, you shake your head. Not possible?
Yeah, there's no good solution there. I mean, the thing is probably, what's going to push that is, there's going to be enough of a hassle living in, we're going to run into problems, right? Some kind of crisis that'll cause this to tip somehow. And I'm not, there's definitely exploiting multi-core is an issue on the JVM style environments, at least when you get to a high enough scale. Maybe this is one point where you could maybe disagree. But of course, the single heap memory model of JVM, it kind of comes. It affects a lot of decisions in the VM and in the system, and that just has some inherent problems in terms of scaling to many cores, where something that has super lightweight processes like Erlang has opportunities, but Erlang has, from a VM engineer point of view, pretty shitty VM from a performance point of view, at least, right? It's nice and stable, but it's dog slow.
Not for doing Erlang stuff, right?
Huh?
Not for doing Erlang stuff.
Why is that?
Well, if you want to do numerical calculations, I agree.
Sure.
It's not fast doing numerics, but if you're doing things like context switching, sending messages, it's fast, right? And that's what it's optimized for. If you want to do numerical calculations,
So it's a language for doing context switching.
Context processes, context switching, concurrency, and fault tolerance. Yes, it's not for doing number crunching. And if you want to do number crunching, then you talk to some other language like C or Fortran, which does number crunching. You do that. And I would say, if you want to access things from the JVM, well, then make your VM talk to the JVM and get it to do stuff for you. That's our suggestion.
Right, so you can build a foreign function interface like
You build
Haskell has an FFI for talking to C,
Yeah.
and it works very nicely. But if you're going to talk to Java libraries, then it really helps if your language is like Java, and has a Java-like type
True,
system and so on.
true, yes.
And if it doesn't, then it's not a very good fit. So then it's questionable whether you really do want to use all those Java libraries, because it would be kind of a bit of a twist to try and use them. But then, yes, you can build some kind of foreign function interface to talk to Java and hopefully manage the sort of shared garbage collection that you'd have to do between the two VMs. That's a bit tricky.
Yeah,
So-
but all this function stuff is always a mess. In Java we threw that away many years ago. In the beginning of Java, there was lots of people put in native code, and it was really nice. You could inherit, you could kind of pull in the native libraries of various kinds then as the VM improved and there was a larger and larger body of code in pure Java, kind of gradually it got to a point where now nobody would touch native code if you can avoid it. Right? It's much nicer if it's just pure Java, because then everything is debuggable and you don't get weird memory leaks outside of your heap, and there's so many benefits, and you can do inlining, nice fast. Hotspot VM will do inlining all the way through your imported library, thing that many people don't really realize. All these cross-module optimizations that happen. So, yeah, that's, in many ways, that's kind of, importing native code is, that's an engineering solution if you have to do it, and that's the best thing you can do in a given context. And, in many ways, Erlang is still at that point where they're, still importing boatloads of NIF code. I call it the NIF monster.
Yeah.
What's a NIF?
Natively implemented function. Yeah, they're for crashing the system. So Alan can handle errors everywhere except in the NIFs, right? Then the system goes down.
So, go ahead.
Yeah, just commenting. I mean, it depends on how different or what requirements you have on your VM, really, whether it's worth doing your own or not. What properties you need.
So let me twist this discussion to another direction, because we were talking about the JVM all the time, but actually that's a red herring, because the future is really JavaScript. Everybody compiles to JavaScript, and we talked about, we have these trade-offs, the big ecosystem that's everywhere. Well, that's not true. There's no Java on this thing, not a single bit of Java. Even on the Android devices, it's not really Java, it's Dalvik. JavaScript is on all these devices, and it's getting faster. And people are using it despite the fact that there's no ecosystem, or tiny little ecosystem. So actually, I think we're talking about the wrong thing. We're all going to go to JavaScript.
There already. No problem.
Which
Sounds good. Good idea.
Rich is as always the thought leader. So when are you going to join in? Where's Haskell? Where's Erlang for JavaScript?
So we have at least 3 Haskell to JavaScript compilers already. That's probably 2 more than you need.
I only need 1.
Fine. Are they any good? The Haskell compilers?
Probably not.
ClojureScript is excellent.
Yes, I can attest to that. Because Rich paid me. No, he didn't.
I mean, they'll work for running smallish Haskell programs, I would think.
Right.
But if you want to do heavily multi-threaded stuff and use lots and lots of libraries, then you'll end up with huge JavaScript files. That's not something you want to squirt over the network very much.
Please.
Now you're talking about the iPad. It's running this ridiculous programming language called Objective-C.
Right. But it's objective. It's nice.
And I happen to have actually worked on it, but I'd say the success of iOS and all this just goes to show that the language really doesn't mean that much. And I'm sitting here thinking, why do we even care about these programming languages? When Objective-C succeeded so big scale, I mean, why even bother?
Well, that's an interesting point. This language succeeded without developers. I mean, 5 years ago, nobody knew Objective-C except for old farts who were around in the 80s, and you, Kresten. And hipsters who were programming for the Mac, and still it succeeded. And the same thing with JavaScript, because nobody cared about JavaScript 5 years ago, and suddenly it took off. So apparently there are some ways to get new languages into new systems accepted if there are enough incentives, like mobile or embedded, where there are no JVMs or where there are no other systems.
But these languages didn't succeed because, on their own merits, right? They succeeded because they came with a platform, and you had no choice.
They succeeded because they tied themselves to the right platform. So to succeed a language has to tie itself to a speeding boat.
To a business, something that has business value,
Yes.
right?
Yeah.
It's all about the problem you're trying to solve somehow, right? I mean, making systems run in a JVM environment manageable, that's your problem here, right? Context switching is his problem, and writing compilers is the last one, right? And if that's where you're trying to get your business value, then maybe that's where you should go looking for it.
But also, I mean, you are forced to use them, in a sense. I mean, irrespective of whether the language is good for what you want to use it for, you don't really have much choice.
Right.
I mean, it's not like I'm going to come with a new language which every browser implementation is going to be using in a year or something like that. That really doesn't happen. And the same thing on the iOS. And if you have the choice of language, of course, you can choose which language you find is easier for your type of application. Then you might get stuck with a certain VM or not.
So choice is the opportunity killer. We need a dictatorship that forces us to use good languages. So who do we bribe to get to Haskell or Erlang or Clojure?
Well, obviously all these guys already did that, you know.
Yeah.
They're not going to tell you.
So yeah, the conclusion is the future is JavaScript. All ditch our compilers. We have a few minutes for comments if you want to tell me off, or if you want to ask our illustrious panel. Hi for Mike. Will travel. Hands up. Only on-topic questions.
No.
With your given VMs, what's your biggest cause of pain? What would be the one thing that you would change to make your life easier? I guess it's a bit more for Rich and Kresten because you have less of a choice.
I want better garbage collection.
What does better garbage collection mean? I mean more flexible?
Handling larger heaps with fewer pauses, shorter
So what
pauses.
about Azul? Don't they solve
Yeah, they
it?
do. That's a good answer.
Finally solve it. Is that, or are there problems? Do you have to
I don't
tune
know.
it?
I couldn't comment specifically on that, but you know, to what Kresten said before, you know, Clojures run on Azul systems with hundreds of cores, and with a great garbage collector, that works great. You know, with huge memory, huge heaps, and lots of cores. So we're all heading there, but the GCs we get with Java are not there yet. So that's what I would want.
So what about, we talked about isolation. Is that something that you would like to see? So in the JVM, you have hundreds of threads, and one thread goes mad. You can't kill it. Is that something that would be useful for you?
It would be useful if it was solved somewhere at the system level. I don't think it's an application level problem. But yeah, it would be nice if if the JVM took care of that.
So,
Well, in my case, the biggest issue is really the lightweight threading. The encoding I have to do is changes the code size by 3x or so. So if there was a native coroutine library, I could do scheduling and top off or something like that, part of the VM. That would also make a big difference.
well, that's coming in Java X+1. It's always there to recursive function. It's always in the next one. It's a typical pattern.
Yeah, I've been waiting for it long enough, so I stopped waiting.
I think we've been waiting for invoke dynamic since 1995. Well,
It's only 17 years, I think.
oh yeah, it's apparently legal now. Java's only legal now. Question? Christ, got to work here. Can we go?
Not so much a question as a comment. I actually worked as manager in Ericsson for about 20 years. And I could discover that if you look at when do you actually get new technology into things? You get new technology and new programming technology in only in one specific circumstance. That's when you're building a completely new product. Never, ever in any other circumstance. People were talking about Objective-C and iOS and Mac. Of course, Apple did it that way. They had a heck of a lot of code already written. Does anyone know any example of when a functional language has been introduced to build a product and change an old product or increase the functionality in an old product? Is there any one example that anyone can give me?
Many that I can't focus on. But there are many, many of our customers who are going from Java or C++.
Just go.
Yeah.
We get requests every week of users going from Java and C++ where they're having scalability issues and they're going over to Erlang. And we're talking major projects here.
Yeah, we get a lot of rewrites of Ruby and Java.
Yeah.
For sure.
It's happening.
So you're saying actual rewrites or
Yeah.
rewrites of existing code bases?
Yeah, the next version is not going to be in the same language, right?
And that's because of the conciseness of closure, or?
Against Java, it often is the higher level aspect, you know. And against Ruby, it's often performance and scalability if people are trying to use Ruby on servers.
So how do these people who rewrite this code, how do they stop their managers being scared of parentheses?
Some of them...
What's wrong with parentheses?
They're nice. I have no problem with them, but
Yes.
people do.
Been moved over a little bit. You know, it's a social problem. I've heard of projects that moved from Java to Clojure that had huge code base, you know, 2 million lines of Java. And they set upon the team we're going to have two things happening. One is a refactoring job of this Java, because it's monolithic. So we have to turn it into these small chunks. And then on a volunteer basis, they asked anybody who wanted to work on the Clojure team. So they had some volunteers. And what would happen is, as people would take this chunk of the big Java project and isolate it, the Clojure team would rewrite it. And so the isolators are making the job easier for the people who are isolating the parts of the system. But they're getting 20 to 1 code size reduction by doing that. And they're doing it in a much faster than the original Java was written. So.
But that's the easy part. The hard part is actually isolating the pieces.
It can be, if it's monolithic in the first place, it can be, sure. But I think the other way these languages get in is because people have systems. And so if you have systems, you have subsystems, and a new subsystem, you know, it's not really like a new product, right? The product's going to do something new, there'll be a new subsystem, and that's a ripe area for a new language.
Also, another thing we're seeing is the whole
Another thing we're seeing and introducing Erlang is the whole black box approach, where they don't really care what's there. And you know, RabbitMQ, eJabberD are just two of the many examples where they start using it, it scales, it's great, and then they start developing and dabbling with it.
Or I'd say that they run into some wall, which I think your example actually was in a sense. It was a code wall.
Right. Oh, and the Ruby people, it's definitely a performance wall, right?
Yeah, scaling wall. They find that they've got the technology, it works and they like it, but they just can't get any further with it, which forces them to do something else.
Which is a problem of the custom VM, I think, with the Ruby. Their problem is garbage collection, threading, whatever you find is a problem.
Is that the custom VM or is it the language itself? I'm asking. I'm sorry, I'm not implying anything because I don't know.
Well, with Ruby we can actually compare because we have JRuby, which targets the JVM.
Yeah, but how does that compare in speed?
Well, it's if people are going to watch this, I'm going to get such a beating. But if Charles Nutter is listening, sorry. The performance of JRuby, the raw numericals of performance isn't much faster than the fastest MRI. This is a native Ruby. It's faster. But I guess one of the big advantages is that in JRuby do have a proper garbage collector or a more scalable garbage collector. But the Ruby VMs have very primitive, non-copying, nothing stop the world.
Okay.
Which are understandable, which are easy to understand and port, but still, and of course, Ruby also has the problem as Python, it's single-threaded. It has a great interpreter lock, which means
And it mightn't be a performance wall, it might just be a complexity wall as well. I mean, you change language and just some things become very much easy to code in different languages because the language provides some features you need. And you just do what you need in the right language. Then you might get stuck with a VM. So if that works out to be Haskell, which is perfect, then you have the Haskell non-VM. So, yeah.
There was another question, wasn't there?
What's the thing you'd like to be able to do that you don't know how to do? What you need people thinking about?
Personally or language-wise or?
So I think we'd all like a garbage collector that scales to multi-core and has no pauses and is perfect in every way. The GC community hasn't figured out how to do this yet, I don't think.
Yeah, slackers. That would solve a lot of problems, yes.
Yeah, same here. Garbage is our biggest problem.
Yeah, I really come to love the Erlang model in general, right? And it obviously has the huge scalability upside that you just run individual garbage collection in each process. But I'd really like, what I'd like to see the kind of the OS portion of Erlang cut out, to have a generic operating system, or like maybe a virtual machine, generic virtual machine that would be ideal for running Erlang on, but you could also run other languages. Right? You could write each of these processes in whatever language you wanted, and you could mix and match. But basically, it's like that would be like a micro operating system in a virtual machine. I think that a system like that would have many advantages. Just like we have the ecosystem of the JVM, I'd like to have the ecosystem of this virtual machine that runs essentially an operating system semantics, but with microprocessors in there. Kind of like the vision of microkernel operating systems. There's a QNX and the Mach operating system that iOS runs, but it's still very coarse-grained. Something that runs with kind of managed code in a microkernel environment. That would give a freedom. Of course, that would give. I mean, it should JIT my bytecode, you know, so I could run Erlang really efficiently and not slow. And context switching. But yeah, that.
Follow-up question to that.
Huh?
So if we'd like to abstract away the operating system parts of Erlang, would you just end up with essentially Linux? And if that's not efficient enough, can you estimate by what factor a Linux process would be too heavyweight in comparison to?
Such a Unix is what we want for them, which is
Yeah, it's like I don't know, a virtual machine that kind of feels like Unix, but you can have processes that are 120 bytes or something like that overhead. Context switching as fast as calling functions inside user space. You know, it would be as much faster in terms of context switching and as the difference between Erlang context switching and Linux context switching in threads and processes, which is definitely quite heavy, both in terms of performance of switching and overhead of process control blocks and stacks and whatnot.
Is that an assumption from 20 years ago, or is that still true today?
You got me there. Well, it's definitely true to the extent that I've seen it. Still need to have a certain amount of memory allocated for a process to be operable. A page of stack and some more chunks, process control blocks and kernel space, etc.
But But if you had that type of VM, wouldn't it be very difficult not to be able to, not to have to restrict what you run in each of these processes?
I'm not sure I understand what you mean.
Well, I mean, one reason Erlang can do it is that the language or the VM itself guarantees that I cannot write something else in another process.
Sure.
I just can't do that. And there's no way, really no way around it. But then you need some form of security, you know, as
Sure, you would want, I mean, essentially Erlang has very close to an object capability security model, except there's some ugly hoops you can jump through, like the global namespace table, and then you can construct your own process identifiers if you want. You can reconstruct process identifiers and other ugly things like that. Okay, if we got rid of those, then you could easily imagine this being built with an object capability system, just like the Mach operating system has it.
So I have a question. So we have a pretty interesting group of people up here, especially like sort of inspired by the Erlang talk this morning, because there was a time where it was like a big experiment. We're going to try all these different kinds of machines and interpreters, and we're going to use Parlog, and we're going to do all these things, and it's really incredible. And it's the same way with when you read about the history of Haskell, right? There was a time when there were like 6 implementations of Haskell, and really now there's only really GHC. Are we reaching this point where there's not that much enthusiasm for starting over because we have these really mature systems? Is the heyday of innovating our runtimes for new languages, is that kind of over because we have things like JVM, we have things like GHC and Beam, which have really eaten up that space, right? Like you guys have done so much work. Maybe people feel discouraged from starting over.
I would say that would be a reason, if you're doing an existing language, not to use an existing VM. I mean, it's a lot of work to do a VM, and if you're going to do your own, apart from, as I said, the fun factor, that you have to do some specific reason for doing it, because the existing VM, for some reason, does not do what I need it to do. It's too big, too small, wrong in some way. Otherwise, it's a lot of work doing it. It's a lot of work keeping it going, because the one you're doing instead of is changing all the time. The language is changing, improving. The VM is improving and adding new features to it. And if you're doing your own, that means you have to keep that going all the time. And as I said, that's a lot of work. I mean, I've done it, but it's a lot of work to do it. If you're doing your own new language, which in some ways is different enough not to use an existing one, then you might have to do it. But doing a new Erlang VM without having a specific reason why the existing one is not what you want. And the same thing with the JVM. Why I need a new Java machine, but the existing JVM for some reason is exactly not what I want, then you might do it.
If you had a tremendous amount of resources to apply to it.
No.
That's also the problem. Who's going to sponsor it?
The bar is much higher now, right?
Yeah.
One of the few projects that actually do that large scale is Google, that are doing both the Go language and Dart are quite large new language projects that actually have teams behind them and resources behind them in many ways. The times are over when you could actually go sit down and write a new parser and compiler and do something simple as a single man project, pretty much. You need to build on all these other things. You could do a JVM language, but it's really difficult. Of course, you did a heroic effort of building an entire ecosystem around a language pretty much on your own. But that was also building on the shoulders of all this other dynamic stuff. So the bar is much higher, and it's just like when I was a kid. I could do like a game program for my Commodore VIC-20 that was as cool as the ones you could buy. When I was 14 years old or something like that. But that's not the case anymore. When you're, and it's It's kind of the same thing with languages, right? The bar is so much higher that you can't really do with serious language. So you need a big team.
So I heard, oh, go ahead.
I was going to say, yes, and just continue that. Doing a serious implementation
is a lot of work. If you want something which is production quality, you actually expect people to use seriously in products. That's a lot of work doing something, a system like that. There's just so many things that need to work, and the details that need to be worked out to do that. It's a lot of effort to do that.
So Kresten has slyly brought up the word bar, and I heard the ding 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 of the bar. So I think we'll close this here. For any further questions, we can. Oh, Joe, you have a question.
Well, it wasn't so much a disagreement, actually. I think I disagree with you all.
Hang on.
As I said in the lecture this morning, I think languages. If the hardware doesn't change, it's like one of these S-curves where you converge upon the best way to program that hardware. And then as soon as the hardware changes, you're faced with a completely different set of problems. So we still don't know how to program FPGAs. If memristas come, we're really not going to understand how to program them. If we can store all human knowledge, about 2 or 3 petabytes of information, we can store everything. So the ratio, somebody was telling me the ratio of communicating data to caching it in energy terms is a factor of 800. So potentially we can cache all human data that's ever been recorded. We'll be able to cache in a single chip on our machines within about 20 years. That will radically change the software and the programming languages and the way we deal with that. So when memristas come along, some smart young guy who's in their 20s today is going to spend the next year, the next 20 or 30 years of their life getting grey hairs, figuring out how to program these damn things. And I think, just inferring what the future is going to be on the last 10 years of hardware development is ridiculous. I mean, here you are saying, my goodness, based on the last 10 years, languages are going to stay the same forever. I just don't believe it. I think I'm going to see just as much innovation, and I don't know where it's going to come from. And that's the exciting thing, because as these new things burst through, I've seen, say, mobile communications go through a theoretical boundary. There's a Nyquist limit, and there were theoretical reasons why you couldn't transmit faster than a certain thing. I mean, we're already seeing. Suppose people make quantum computers, right? Are they going to be programmed in Haskell or Erlang? No, of course not. They're going to be programmed in... No, I mean, there are... I think you've got to look to physicists and things. You've got to look to those. When they invent the new technologies, they will invent the new things that come. And I don't know when they're going to come, and it's all pretty exciting, actually.
So I think we've all been taught about the truth by the mustachioed sage, Joe. That's a good way to stop. I believe there's beer and stuff out there. And I think Francesco. And thank you to the panel.